Shuttle landing is one thing, but a shuttle launch is something extreme. On April 12, 1981, the initial voyage of Space Shuttle Columbia paved the way for all future shuttle missions. It was the first time solid rocket propellant was used for human spaceflight, and also the first time a new spacecraft launched humans without an unpiloted orbital test flight. STS-1 was in fact a test flight with 2 astronauts on board.
The solid rocket boosters, I mean, you light them and then you go. And there's no way to turn them off. There's no way to throttle them back.
As the astronauts say, when the solid rockets ignite, you know you're going somewhere.
The whole thing is shaking. It's difficult to write. It's difficult to reach any switches, anything like that. So in ascent, the space shuttle is very, very violent. It has a lot of vibration, especially in first stage.
I have witnessed, I think, 6 launches. It's an awesome experience. I cried the first couple of times because there was just this overwhelming feeling of how awesome it is that we can accumulate that much power in a vehicle to lift people in the vehicle off the Earth and send them into space. It's very moving, it feels very patriotic.
A countdown marks each point in the pre-launch sequence. At T-minus 6 seconds, the orbiter's 3 main engines ignite, but stage 1 of the launch begins when the countdown reaches T-minus 0. That is when the solid rocket boosters fire up and the shuttle leaps off the launch pad. At 20 seconds, the shuttle rolls 180 degrees onto its back.
It rolls around this external tank, and so the space shuttle's sitting out here, so it feels like you're on the end of a merry-go-round when it turns, and so when it rolls on its back or something, you feel like you're being swung on the end of a merry-go-round. So it's quite an interesting experience.
At 60 seconds into the launch, the main engines attached to the orbiter are set to full throttle. At 2 minutes into the launch, the solid rocket boosters burn out, separate, and begin their journey back down to Earth. Parachutes packed into the nose cones slow the fall to a predetermined spot in the ocean. Highly trained divers carefully drain the water from the boosters and insert a plug so they float. Then, specially designed ships tow them back to port to be cleaned and used again. Reusing the solid rocket boosters was an innovative cost-cutting feature. Stage 2 of the launch sequence begins as the orbiter main engines continue to consume the liquid propellants from the external tank. Then, at 8.5 minutes, the tank is empty and the main engines shut off. The tank separates from the orbiter and falls down through the atmosphere, burning up in the process, not to be used again. The orbiter is now circling Earth.
It only takes 8.5 minutes to go from Earth to orbit, covering about the same distance as a flight from Boston to New York. That flight would take a normal commercial airliner more than an hour. So how do you get a space shuttle moving that fast? Thrust, and lots of it. Here's a simple equation that will help explain why so much thrust is needed to get the shuttle moving. F equals ma. F stands for the force, the amount of energy you need. M stands for mass, or the amount of matter in something. And A stands for acceleration, a change in speed or direction. The bigger the mass, the more force is needed to balance the equation and get the object to accelerate. Think of pushing 2 different objects, a school bus and a bike. If you had to try to push each across a parking lot in the shortest amount of time, which would you want to push? Now, the space shuttle weighs the same as 180 school buses. Can you imagine the amount of force you would need to get all those buses moving?